The question says, a pellet of mass 100 grams fired from a gun travels at a speed of 30 meters per second and it strikes a block of wood of mass 1.5 kg which is suspended by the length of 4 meters as shown in the figure below. So this is a ceiling and or a fixed point when this block is hanging by this string and it has a mass of 1.5 kg. Then a pellet, or for example, a bullet comes and it hits this one, then they move together after sticking and coming to this position. Now the question is, if the pellet gets stuck, what is the maximum angle, which is this theta, that must be made by the string after impact? So this is the question that we have. So without even wasting time, we can come up with the data. So we have the mass of the pellet, which is 100 grams. Then we have the mass of the bullet of the block, which is 1.5 kg. Then we have the speed of the pellet. So speed, which is 30 meters per second. And since this is at rest, the velocity of the block here, which is the initial velocity, is 0. So from this, what else do we have? We have length, which is L, 4 meters. So this is L. And so from this point to this point, it is also L. Okay. Okay. What else do we have? Okay, I think we're done. Now, in order for us to find the maximum angle, we need to compare this. We know that when this is moving, or we are going to use the principle of energy conservation. Let me erase the top part here. Energy conservation principle. So according to energy conservation principle, energy can neither be created nor destroyed, but can only be converted from one form to another. So this energy, the energy that this block has, or this pellet has, and the energy that this has, and the energy that is going to be acquired from this point, should just be changing from one form to another, which is the mechanical energy initial must be equal to mechanical energy final. So this one we have, so the energy for this, so we have Ke pellet plus potential energy pellet plus Ke block plus Pe block. Then we have Ke pellet plus Pe, oh, this is the pellet, okay. Pe pellet plus Keb block plus Pe block final. But of course we know that this one, when it is coming, when this bullet or pellet is coming, it has some half mPVP squared plus the potential energy, since it is moving, is 0. The kinetic energy at B here is 0. Then the potential energy of B here for initial, it is also 0, which must give us the kinetic energy when it gets to this point. It will be 0 plus the potential energy. Okay, pellet, we are going to have MPGH. It is going to have some energy here when it ascends to this height. Okay, so from this point to this point, it is going to have some energy. And then for the kinetic energy, when it comes to this, it will be 0 plus the potential energy of the block also, MBGH. So this is the equation. Let me erase this and let us continue and see and finish if we can. Let me also erase the same thing. So what we're going to have here is we have this one, mp bp squared, which will give us mp gh plus mb gh. But we see that gh and gh is common. So here we can say this one mp bp squared, which is equal to, we have here, we have gh, okay, mp plus mb, okay, which is simply, okay, so we can divide it through by this mp plus mb g, so that this and this will go, this and this will go, and what we're going to have is mp plus mb. So from this point, let us do some mathematics. Let us draw the diagram one more time. So this is the first method that we have used to derive as using the mechanical energy. And so this is the diagram of which we know that from this point, when it is displaced, we have okay. So this is L, and the same length. It is the same length. This is the same thing. It is just displaced from this point to this point. Now, when it is displaced from this rest position to this, the displacement is simply h, which is the height. Now, from this one, without even going to this, if we want, we know that this is the moving, there is a value that is moving in this direction. We can simply say this one, the mgh, this side we just have half mpv squared, because it's the only one that is moving. This is 0. So for this one, it is 0 because it is not moving. Then this must give us this one. When it sticks in this one, it is going to have a combined mass. So we're going to have mgh, potential energy, mgh, of which we know that m is going to be mp plus mb. So this one can be written as mpvp squared, which will give us mb plus mp gh. If we make h the subject, we are going to have this expression. So if you want, you can use this one by saying total kinetic energy is equal to total potential energy. So if this is the shortest, this after drawing, you can come up with this. It is going to give you the same answer, but for the sake of understanding, I decided to go this way. So from this point, we are going to derive now for h and then plug it in so that we can come up with the angle. Let me erase this. Here we have got this one now from Sobatoa. We know that this is the angle. This is the angle. And the side that is adjacent to the angle is x. So we have cos theta is equal to x over L. This is opposite and this is hypotenuse, and we're going to have x is equal to L cos x. So if from this point to this point is L, and from this point to this point is x, then h is L minus simply x, h plus x should be equal to L. X plus h should be equal to L. So that h will be equal to L minus x. And x is equal to L cos theta. So cos theta. So we can plug in this into this. We're going to have L minus L cos theta, which will give us mp dp squared over 2g mp plus mb, which we can proceed by saying, so this is L. L is common, so we can factor out L. Then here we're going to have 1 minus the cosine of theta, which will give us, so we can divide it through by L. Okay, even here by L. So this and this will go, we're going to have 1 minus cos theta will give us. So this one can come this side, and we are going to have, so this one will be minus. So we have 1 minus, this will give us the cosine of theta. So from this point, we can plug in the values, or simply by saying, okay, this is cos theta will be equal to 1 minus, we can plug in the values. Mass of the pellet is 100 grams, which is simply 0.1 kg times 30 squared over, so this one we have 2 times G, 9.8 times L, which is 4. Then here we have mass of pellet, which is 0.1 plus mass of block 0 or 1.5. So this one is going to, we are going to have 0.2825 as the cosine of theta. So cos theta, or simply theta, will be equal to the cos inverse of 0.2825, which will give us